NCERT Physics Class 11th, 5th chapter, which is Laws of Motion, question number 5.3. Give the magnitude and direction of the net force acting on a stone of mass 0.1 kg. So a stone of mass 0.1 kg is given and we have to define the magnitude of force acting on it. In first part, just after it is dropped from the window of a stationary train. So a train is given to us. When the particle is just released from the train, we have to define the force acting on it. So if a particle is dropped from the window of a stationary train, we can see that from this the force acting on the particle is only mg, and mass is given 0.1 kg. This implies the value of force is equal to 0.1 into g, that is equal to 10. So force is equal to 1 Newton in downward direction. Coming to B part. In B part, just after it is dropped from the window of train running at constant velocity of 36 km per hour. So in this case, the train is moving with velocity v, and you had dropped the stone from it. So just after dropping the stone, the only force acting on it is mg. So in this also, the net force is equal to 0.1 into z, that is 10. This is equal to 1 Newton in downward direction. C part, just after from a window of a train accelerating with this 1 meter per second square. So in C part, the train is accelerating with acceleration is equal to 1 meter per second square, and you had dropped a stone from its window. And just after dropping, as we can say that after the stone is being dropped out of train, it does not have any contact with train. So it will have only force, which is mg, acting in downward direction. So from this we can say the net force acting on this is 0.1 into 10, which is equal to 1 Newton in downward direction. Coming to part D. In D part, what is saying that stone is lying on a floor of train which is accelerating 1 meter per second square. The stone being rest relative to train neglect air resistance. So in part D, the stone is lying on the surface of train, and train is accelerating with an acceleration of 1 meter per second square, and we have to define the net force. So in this case, the acceleration is equal to 1 meter per second square, and we have to define net force. So in order to find net force, first draw the FBD of the given system. For FBD, we can say that net force acting on the system is as normal in upward direction, mg in downward direction. As we can see that the stone is moving with train without slipping, it means if the train has acceleration of 1 meter per second square, then stone will have also acceleration of 1 meter per second square in forward direction. In order to have this acceleration in forward direction, a friction force acting on its surface. Let's say this friction force is equal to F. So we can say that normal is equal to mg, as the particle is not moving in vertical direction. So normal is equal to mg. So vertical force, so net force in vertical direction equal to 0. This implies that net force in vertical direction equal to 0. So net force is acting in horizontal direction, which is equal to net force acting on particle is in horizontal direction, which is equal to F. And this friction force is equal to m into A. So net force acting on particle, that is equal to 0.1, mass is 0.1 into acceleration, which is 1. This is equal to net force is equal to 0.1 Newton in forward direction or in direction of acceleration of train.